Hi class 12, let's continue our class. So far we have done Ampere circuital law, isn't it? That is uh, close or line integral of B dot dl equals to how much? Mu naught I inside, isn't it? Right. So today we'll start with solenoid, isn't it? So I hope you thought that a solenoid, isn't it? And see what I want to say is that a current carrying conductor behave as a magnet, isn't it? You learned, isn't it? Already learned, isn't it? So this is your current carrying wire. If you place a magnet, isn't it, then it will deflect, isn't it? यो पढेको 9 मा किन चाहिँ डिफ्लेक्ट हुन्छ भन्दा नि अब म्याग्नेट अर्को म्याग्नेट ल्यायो भने त्यसरी तिमीले गरेको थियौ एक्सपेरिमेन्ट, isn't it? किन डिफ्लेक्ट गर्छ? ड्यू टु it behave as a magnet. See, this current carrying wire behave as a magnet. Clear? So today we'll start with solenoid, isn't it? Solenoid is a winding of wire, isn't it? Straight winding of wire. So first item, the solenoid. Solenoid चाहिँ यस्तो हुन्छ, अलिकति त हेरेको छ, isn't it? क्लास 10 मा पुरा हेरेको छ तिमीले. So this is your solenoid, isn't it? Like a spring. Clear? So you also learned that, see, if I flow current like this, goes up, isn't it? Goes and goes, isn't it? So see, this one is going like this, isn't it? So this is what? Circular wire, isn't it? So this behave as south pole, isn't it? And this, if you see, then you'll get this type, isn't it? And this is your north pole, isn't it? यस्तो बनाएको गरेको हैन. So magnetize गरेको हुन्छ हो. Next chapter ma we'll see. Okay, clear? So today we'll talk about if you have the solenoid. Clear? So what is the magnetic field of this solenoid, isn't it? So simply outside the solenoid, magnetic field be always zero. Okay, outside चाहिँ के हुन्छ? Zero हुन्छ magnetic field. याद राखिराख्नु. Outside the solenoid. Okay, तिमीले खाली के गर्नुपर्छ? Inside the solenoid there is magnetic field. If this is what? South and this is north, then inside a magnet, see, magnetic field is start from north to south, outside, isn't it? Inside, south to north. So inside, how much? South to north. So this is the magnetic field. Okay, direction of magnetic field. Clear? So तर के हुन्छ? Magnetic field is strength of this wire solenoid we have to find, isn't it? हाम्रो. So के हुन्छ भने नि, just take a rectangular, see, this is take as dot dot dot. Okay, यस्तो छ तिम्रो solenoid. उँभो आउँदैछ यहाँ magnetic sorry current, and यहाँ कस्तो छ? उँधो जाँदैछ current, direction of current. Okay, so you have to take Ampere's circuital law. You have to take a rectangular loop. Okay, so this is your rectangular loop. Clear? So name पनि बनाऊ, ABCD, ABCD. So this is what the direction of magnetic field. Okay, and this is your outside चाहिँ के हुन्छ? North to south, isn't it? Inside, south to north. This is the direction of magnetic field. But we have to find strength of magnetic field, isn't it? अब यो बाहिर त 0 हुन्छ, isn't it? यो भित्र, यो भित्रको बनाएको. Okay, okay. So हेर, बाहिर त 0 हुन्छ सो यो त अपोजिट छ कि डाइरेक्सन अफ म्याग्नेटिक फिल्ड कस्तो छ अपोजिट छ सो के हुन्छ यो मात्रै बच्छ हो कि नेट क्लियर सो पेज नम्बर हेर तिमीले 151 सो के गर लेट द नम्बर अफ लेट n be the number of turns per unit length भन्नु मतलब per unit length how many number of turns are there wire त यसरी रहेको छ नि हैन so n times isn't it so again let length this is the length isn't it so or you can say length of ampere in loop L equals to let h okay h is the length okay cylinder ko height bhancha kasैले okay so length okay so current कति हुने रहेछ so many turns isn't it so write down so total number of turns per unit length कति भयो यसमा per unit लेख्दैछ per unit length के हुन्छ the number of turns into the length isn't it h clear so अब के गरे यति understood त पहिला पनि गराएको थिए मैले okay so now you have to find current isn't it why because we are using this law okay so shall I rub this one so you'll get current find current how much is your current so current enclose IE means current enclose the loop okay so how much I into NH isn't it number of turns current isn't it so we also know that by Ampere's law by Amperian circuital law what we know B dot dl isn't it so here just put B dot dl means L isn't it length of the wire isn't it sorry length of the wire yes equals to mu naught times current enclosed how much I and H so also we know that B dot this is how much L is how much NH isn't it N into H so equals to how much mu naught I and H right sorry this is not happening L is what H isn't it length kati cha height on the height of the cylinder isn't it so this equals to how much H cancel so B equals to how much mu naught number of turns N is your number of turns and multiple of current so this is your magnetic field inside the solenoid clear by Ampere circuital law clear so if you confused then turn page number 152 will clear there so next is your toroid okay toroid यो solenoid को यो advance okay अलिकति ठुलो so toroid okay toroid चाहिँ कस्तो हुन्छ सो यस्तो हुन्छ सिलिन्ड्रिकल ओके गएर सर्ट टाइम यस्तो हुन्छ ओके सर्कुलर ओके सोलिनोइड bend with like in the shape of circular okay so here अब हेर Q this portion. If you like to find magnetic field over here, 0. Inside also 0 you'll get P. Inside पनि 0 हुन्छ. Okay, यो याद राख्नु. And inside the toroid you have some magnetic field. Okay, त्यो चाहिँ तिमीले find गर्नुपर्छ. Okay, if I flow current like this, then this is how that you can understand, isn't it? सब के गरे यसलाई काटेर बनाइदिएको छ मुनि फिगर. क्लियर? यो राम्रो हेर, बुकमा छ कि फिगर. So see, this is your point P and this is your loop 1. Okay, with radius R1. Okay, and this is the part of toroid, and this is your second loop, that is your inside the toroid. Clear? And this has radius R, and this is your again a part of toroid. Okay, and this is your third loop, impedance loop. Dot dot मा जे छ त्यो चाहिँ के हो? Impedance loop. Okay, so this has got radius as R3. Clear? So here this is point Q, this is let as inside the toroid, and this is your P. So already we know that magnetic field at Q and P equals to 0, isn't it? B at Q and P equals to 0, isn't it? Right? So we left with this one, this S, isn't it? So find this. So this is your circular, isn't it? So circumference of circle how much? 2 pi r, isn't it? 2 pi r लेखिराख. Okay, then let's find B, the magnetic field at S inside the toroid. Okay, so write down L equals to how much? The length of the loop equals to how much? 2 pi r, isn't it? Length of the loop 2 pi r. Why? Because this is your radius, isn't it? R. Next, see again, number of turns. Let the number of turns be n. Okay, so current how much? Current enclosed, I enclosed equals to how much? Ni, isn't it? Yes or no? The number of turns into the current. So therefore by Ampere circuital law, देख्दैछ देख्दैन होला के हुन्छ? See, line integral of see this one, isn't it? Line integral of V dot dl equals to how much? Mu naught times the current enclosed, right? Or inside पनि भन्छ. Okay, so put this one. So B line integral how much? L equals to mu naught I enclosed here Ni, isn't it? Clear? So here B equals to mu naught Ni divided by L. L कति छ? L पहिले लेखिराखौँ. So B equals to mu naught Ni divided by L 2 pi r. Understood? So again, understood this one. So again you can change this n. Okay, number of turns equals to how much? 2 pi r, the number of the wire, isn't it? Yes or no? So n, write down B equals to mu naught 2 pi r n into I divided by 2 pi r. So n equals to how much 2 pi r into n average निकालेको okay so 2 pi r gone so b equals to how much mu naught n I same I can argue here. So toroid and solenoid got the same magnitude of magnetic field, right? So त्यति लेखा आज हो. Then on page number 154 in example छ okay so do this one. यस्तै गर्न सजिलो आउँछ ल एक्जाममा तिमीहरुको यसपालि सजिलो आउँछ. This much for today. Thank you class.